So here we will be learning about perpendicular axis theorem and a new term that is called as polar moment of inertia. So as we know that Ixx and Iyy are the moment of inertia that gives the measure of resistance to bending about an axis. So here this polar moment of inertia in circular shaft, it gives measure of resistance to twist about a perpendicular axis. Now if this is a circle over here like this, okay, if we consider this particular plane lamina here, so it gives the measure of resistance to the twist or whenever you apply torque. Okay, to find out the mathematical equation of this, so let us consider this plane lamina, okay, and xy is a xy with the axis, and z axis will be towards the outward of this plane lamina. Now if we consider a small area over here, that is dA, about a distance of y and here x, okay, and it is located from the center. You can take this point as radial distance is r, or you can write it in small r. Radial distance from the center of this particular area is r. Okay, now from the z axis, if you take the moment of inertia, we get the product of area and square of the perpendicular distance, the square of the perpendicular distance, so that will be nothing but di zz dash is equal to, of this particular small area, it will be perpendicular distance square of perpendicular distance x square into dA. Integrating this equation, we will get the polar moment of inertia of this entire lamina. So we can write this as Izz is equal to integration of r square into dA. Okay, so this is the polar moment of inertia about the perpendicular axis. Okay, so since we know that this particular r, radial distance r, can be expressed as x square plus y square, so the polar moment of inertia can be determined as Izz is equal to point here, polar moment of inertia IP, integration of x square plus y square into dA. So this can be written as integration of x square into dA plus integration of y square into dA. So we get it as Ixx plus I subscript y. Thus we can see that in the plane lamina, the polar moment of inertia is equal to a sum of two mutually perpendicular axes in the plane lamina. The polar moment of inertia is useful for calculating the stress when the structural member is subjected to torque as in a shaft. Okay.